Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today's video, we are going to continue on with the Junior Penetration Tester learning paths out of TryHackMe. This is the Introduction to Web Hacking section. SQL injection is the name of the room. Learn how to detect and exploit SQL injection vulnerabilities. Now, let's go ahead and jump into it. Task 1, brief. SQL, or SQL, Structured Query Language Injection, mostly referred to as SQLi, is an attack on a web application database server that causes malicious queries to be executed when a web application communicates with a database using input from a user that hasn't been properly validated. There runs the potential of an attacker being able to steal, delete, or alter private and customer data, and also attack the web application authentication methods to private or customer areas. This is why SQLi is one of the oldest web application vulnerabilities, and it can also be the most damaging. In this room, you'll learn what databases are, what SQL is with some basic SQL commands, how to detect SQL vulnerabilities, how to exploit SQLi vulnerabilities, and as a developer, how you can protect yourself against SQL injection. What does SQL stand for? Well, we already know that from up here. SQL stands for Structured Query Language. So let's go ahead and put this in here. Continue on to task number 2. What is a database? If you're not used to working with databases or exploiting them, there's probably some new terminology to get used to. So let's start with some basics on how databases are structured and how they work. What is a database? A database is a way of electronically storing collections of data in an organized manner. A database is controlled by a DBMS, which is an acronym for Database Management System. DBMSs fall into two camps: relational and non-relational. The focus in this room will be on relational databases. Some common ones you'll come across are MySQL, Microsoft SQL Server, Access, PostgreSQL, SQL, and SQLite. We'll explain the difference between relational and non-relational database at the end of this task, but first, it's important to learn a few terms. Within a DBMS, you can have multiple databases, each containing its own set of related data. For example, you may have a database called Shop. Within this database, you want to store information about products available to purchase, users who have signed up to your online shop, and information about the orders you've received. You'd store this information separately in the database using something called tables. The tables are identified with a unique name for each one. You can see the structure in the diagram below. But you can also see how a business might have other separate databases to store staff info on the accounts team. All right, here's the example of the infographic here. You got the database server, and inside there, you got this um, different databases in there. One is called shop, staff, and accounts, and you got tables of each one, users, product, orders, etc., etc. Let's continue on. What are tables? A table is made up of columns and rows. A useful way to imagine a table is like a grid with the columns going across from left to right, containing the name of the cell, and the rows going from top to bottom, with each one having the actual data. And here's what an table looks like here. You got the rows up and down, columns going left to right. All right, ID, username, password, and the information inside those cells there. All right, columns. Each column, better referred to as a field, has a unique name per table. When creating a column, you also set the type of data it will contain, common ones being integers, numbers, strings, standard text, or dates. Some databases can contain much more complex data, such as geospatial, which contains location information. Setting the data type also ensures that incorrect information isn't stored, such as the string hello world being stored in a column meant for dates. If this happens, the database server will usually produce an error message. A column containing an integer can also have an auto increment feature enabled. This gives each row of data a unique number that grows increments with each subsequent row. Doing so creates what is called a key field. A key field has to be unique for every row of data, which can be used to find that exact row in SQL queries. Rows. Rows or records contain individual lines of data. When you add data to the table, a new row/record is created. When you delete data, a row/record is removed. Relational versus non-relational databases. A relational database stores information in tables, and often the tables share information between them. They use columns to specify and define the data being stored, and rows actually to store the data. The tables will often contain a column that has a unique ID primary key, which will then be used in other tables to reference it and cause a relationship between the tables, hence the name relational. Non-relational databases, sometimes called NoSQL, on the other hand, are any sort of database that doesn't use tables, columns, and rows to store the data. A specific database layout doesn't need to be constructed, so each row of data can contain different information, giving more flexibility over a relational database. Some popular databases of this type are MongoDB, Cassandra, and Elasticsearch. Now that you've learned what a database is, let's learn how we can actually talk to it using SQL. It says, what is the acronym for the software that controls a database? Well, that was the database management system, as we saw up above here. I didn't scroll past. There we go. DBMS. So let's go ahead and type that in there. DBMS. What is the name of the grid-like structure which holds the data? Well, that's going to be the table. This is talking about rows and columns, right? So it's going to be table. Task number 3. What is SQL? SQL or SQL stands for Structured Query Language, is a feature-rich language used for querying databases. These SQL queries are better referred to as statements. The simplest of the commands, which we'll cover in this task, is used to retrieve, select, update, insert, and delete data. Although somewhat similar, some database servers have their own syntax and slight changes to how things work. All of these examples are based on a MySQL database. After learning the lessons, you'll easily be able to search for alternative syntax online for the different servers. It's worth noting that SQL syntax is not case sensitive. Select. The first query type we'll learn about is the select query used to retrieve data from the database. And this is an example of what it looks like. Select star from users. So it's going to be select everything from users, right? And if you take a look here, this is what's in the table. The first word select tells the database we want to retrieve some data. The star tells the data we want to retrieve back all columns from the table. For example, the table may contain 3 column IDs, username, and password. From users tells the database we want to retrieve the data from the table named users. Finally, the semicolon at the end tells the database that this is the end of the query. The next query is similar to the above, but this time, instead of using the star to return all columns in the database table, we are just requesting the username and password field. So select username and password from the users table. Okay, now let's go ahead and continue on here. The following query, like the first, returns all the columns by using the star selector and then the limit 1. Clause forces the database to return only one row of data. Changing the query to limit 1, 1 forces the query to skip the first result, and then limit 2, 1 skips the first 2 results, and so on. You need to remember the first number tells the database how many results you want to skip, and the second number tells the database how many rows to return. All right, so make sure to take note of that. All right, and let's continue here. So you got limit 1, so they just want to look at the first row there. Lastly, we're going to utilize the where clause. This is how we can finally pick out the exact data we require by returning data that matches our specific clauses. Select star from users where username equals admin, and here's what it looks like. This will only return the rows where the username is equal to admin. And there's another one here. It says select star from users where username does not equal admin. So it's the opposite. This return rows where the username is not equal to admin. And you have another one that says select star from users where username equals admin or username equals John. So they're going to be it's going to bring back results for admin and John where that pops up in there, as you can see there below. This will only return rows where the username is equal to admin or John. And the next one is select star from users where username equals admin and password equals that password there, and that's going to show the results. They only show the username admin and then that correlating password. Using like clauses allows you to specify data that isn't an exact match, but instead either starts, contains, or ends with certain characters by choosing where to place the wildcard character represented by a percentage sign. And you have select star from users where username like a percentage sign and it's going to bring up this result here, ID number 2, username admin, and then the correlating password. This returns any rows with a username beginning with the letter A. Select star from users where username like percentage sign n. Since this returns any rows with a username ending with the letter n. So, okay, the first one's looking for starting, the next one's looking for ending. Okay, and the next one says select star from users where username like percentage mi percentage. This returns any rows with the username containing the characters mi within them. Union. The union statement combines the results of two or more select statements to retrieve data from either side or multiple tables. The rules to this query are that the union statement must retrieve the same number of columns in each select statement. The columns have to be of similar data type and column order has to be the same. This might sound not very clear, so let's use the following analogy. Say a company wants to create a list of addresses for all customers and suppliers to post a new catalog. We have one table called customers with the following contents, and that's what it looks like here, and another called suppliers with the following contents. Using the following SQL statement, we can gather the results from the two tables and put them into one result set. And then here's what the query looks like. Select name, address, city, yada, yada, yada. Union select company address, city, yada, yada, yada. All right, and that's what the information is or looks like when it's combined together. All right, so let's go ahead and continue on to insert. The insert statement tells the database we wish to insert a new row of data into the table. Into users tells the database which table we wish to insert the data into. Username, password provides the columns we are providing data for, and then values Bob password provides the data for the previously specified columns. Insert into users, username, password, values Bob, password 123, right? The username is going to be Bob, then the password is going to be password 123, all right? Update. The update statement tells the database we wish to update one or more rows of data within a table. You specify the table you wish to update using the update percentage sign table name percentage sign set, and then select the fields or fields you wish to update as a comma separated list, such as username equals root, password equals pass123, and then finally select or similar to the select statement, you can specify exactly which rows to update using the where clause, such as where username equals admin. And this is what the example looks like here. All right, so let's continue on. Delete. Delete statement tells the database we wish to delete one or more rows of data. Apart from missing the columns you wish to return, the format of this query is very similar to select. You can specify precisely which data to delete using the where clause and the number of rows to be deleted using the limit clause. Delete from users where username equals Martin. So it's going to find that user Martin and delete it. Right? Delete from users. Because no where clause was being used in the query, all data was deleted from this table. Oh, okay. Well, I guess you have to be careful with that, right? You don't want to accidentally do that. What SQL statement is used to retrieve data? And that was select. What SQL clause can be used to retrieve data from multiple tables? Well, we saw that was the union. And then what SQL statement is used to add data? And to add data was insert, I believe. So there we go. Now let's go ahead and continue on to task number 4 here. What is SQL injection? What is SQL injection? The point wherein a web application using SQL can turn SQL injection is when user provided data gets included in the SQL query. What does it look like? Take the following scenario where you've come across an online blog and each blog entry has a unique ID number. The blog entries may be either set to public or private depending on whether they're ready for public release. The URL for each blog entry may look something like the following. You got website.thm blog question mark ID equals 1. From the URL above, you can see that the blog entry selected comes from the ID parameter in the query string. The web application needs to retrieve the article from the database and may use a SQL statement that looks something like the following. Select star from blog where ID equals 1 and private equals 0, limit 1. From what you've learned in previous tasks, you should be able to work out that the SQL statement above is looking in the blog table for an article with the ID number of 1 and the private column set to 0, which means it's able to be viewed by the public and limits the results to only one match. As was mentioned at the start of the task, SQL injection is introduced when the user input is introduced into the database query. In this instance, the ID parameter from the query string is used directly in the SQL query. Let's pretend article ID 2 is still locked as private, so it cannot be viewed on the website. We could now instead call the URL, which looks like the following here, which could then in turn produce this SQL statement, right? You got ID equals 2, right? So star from blog where ID equals 2, and you got dash dash in there, and private equals 0, limit 1. The semicolon in the URL specifies the end of the SQL statement, and the two dashes cause everything afterwards to be treated as a comment. By doing this, you're in fact running the query. It looks like the following here, star from blog where ID equals 2, which will return the article with an ID of 2, whether it is set to public or not. This was just one example of SQL injection vulnerability of a type called in-band SQL injection. There are 3 types in total: in-band, blind, and out-of-band, which we'll discuss over the following task. What character signifies the end of a SQL query? As we saw that, it's going to be the semicolon. And we're going to go to task number 5 here, and we need to start up the machine. So let's go ahead and start this up and continue on. Hey everybody, just a quick little blurb here. As you can see here, most people that view my channel are not subscribers. If you're new here, please consider subscribing to the channel. If you're enjoying the video, please consider hitting the like button. It helps get me in the algorithm, helps spread the good word out there, helps bring more people and increase our glorious community here. All right, I'm all about helping out others. I know what it's like to come up in cybersecurity or even try to get into cybersecurity and not knowing where to look. I'm just having this channel up so I can help out other people. All right, that's all I got. All right, task 5, and we're going to talk about this in-band SQLi. In-band SQL injection is the easiest type to detect and exploit. In-band just refers to the same method of communication being used to exploit the vulnerability and also receive the results. For example, discovering an SQL injection vulnerability on a website page and then being able to extract data from the database to the same page. Error-based SQL injection. This type of SQL injection is the most useful for easily obtaining information about the database structure, as error messages from the database are printed directly to the browser screen. This can often be used to enumerate a whole database. Union-based SQL injection. This type of injection utilizes the SQL union operator alongside a select statement to return additional results to the page. This method is the most common way of extracting large amounts of data via an SQL injection vulnerability. Practical. All right, so we've already started up the machine. Each level contains a mock browser and also SQL query and error boxes to assist in getting your query slash payload correct. Level 1 of the practice lab contains a mock browser and website featuring a blog with different articles, which can be accessed by changing the ID number into the query string. The key to discovering error-based SQL injection is to break the SQL codes or the code SQL query by certain characters until a error message is produced. These are most commonly single apostrophes or a quotation mark. Try typing an apostrophe after the ID equals 1 and press enter, and you'll see this returns a SQL error informing you of an error in your syntax. The fact that you've received this error message confirms the existence of an SQL injection vulnerability. We can now exploit this vulnerability and use the error messages to learn more about the database structure. So they said they wanted us to put this in here somewhere, right? Okay, so all right, ID equals 1. Let's go ahead and put this single quote in here, or apostrophe, and hit enter, and there's the error message. All right, so let's go ahead and see what they're talking about down here. The first thing we need to do is return data to the browser without displaying an error message. Firstly, we'll try the union operator so we can receive an extra result if we choose it. Try setting the mock browser parameter to union select 1. Okay, so let's try that. All right, so union select 1. Let's try this. So 1 and then union select 1. Let's see if this works. All right, so let's do this here. Different number of columns. This shows an error message from you that the union statement has a different number of columns than the original select query. So let's try this again, but add another column. All right, so let's go ahead and do that. 2, different number of columns. Same error again. Let's try this again with 3, different number of columns. Okay, success. All right, something is wrong with mine. Oh, all right. Sorry about that. Let me go and fix this real quick. There we go. Now we got it. Success error message has gone and the article is being displayed. But now we want to display our data instead of the article. The article is displayed because it takes the first result somewhere in the website's code and shows that. To get around that, we need to first query to produce no results. This can be simple or simply be done by changing the article ID from 1 to 0. So let's go ahead and change that for this 1 and replace it with a 0. All right. Now, you'll now see the article is just made up of the result from the union select, returning the column values 1, 2, and 3. We can start using these return values to retrieve more useful information. First, we'll get the database name that we have access to. You'll now see, okay, so let's go ahead and try this real quick. I'm going to type in database, then open and close parentheses. Database, open and close, enter. And let's see, you'll now see where the number 3 was previously displayed. It shows the name of the database. So what did I do wrong? I didn't take out 3. Now let's delete that out of there. Let's try this again. There we go. On our next query, we'll gather a list of tables that are in the database. So I'm just going to copy and paste this. It's a long query. And let's go ahead and delete all this stuff out of here. All right, we've got article staff and users. There are a couple of new things to learn in this query. Firstly, the method group underscore concat, open and close parentheses, gets the specified column. In our case, table underscore name from multiple return rows and puts it into one string separated by commas. The next thing is the information underscore schema database. Every user of the database has access to this, and it contains information about all the databases and tables the user has access to. In this particular query, we're interested in listing all the tables in the SQL underscore 1 database, which is the article and staff underscore users. As the first level aims to discover Barnes' password, the staff underscore users table is what interests us. We can utilize the information underscore schema database again to find the structure of this table using the below query. So let's go ahead and try this here. So I'm going to copy and paste this again and replace all this information out of here. Here we go. And let's see. Yeah, ID, password, and username. This is similar to the previous SQL query. However, the information we want to retrieve has changed from table underscore name to column underscore name. The table we are querying in this information underscore schema database has changed from tables to columns, and we're searching for any rows where the table underscore name column has the value of staff underscore users. The query results provide 3 columns for the staff underscore users table, ID, password, and username. We can use the username and password columns for our following query to retrieve the user's information. So let's go ahead and try this here. Copy and paste again. All right. Now let's see what it looks like. There's the password and the corresponding username together. Again, we use the group underscore concat method to return all of the rows into one string and make it easier to read. We've also added the comma, single quote, colon, single quote, comma to split the username and password from each other instead of being separated by a comma. We've chosen the HTML, it's a break tag, or yeah, that forces each result to be on a separate line to make for easier reading. You should now have access to Martin's password to enter and move to the next level. And here's Martin's password. So let's go ahead and copy and paste this and continue on to task number 6. So check password. Let me get this out of there. All right. Oop. All right, and here is the flag right here. Let's go ahead and take this, plug it in, and then we'll continue on to task number 6. Task 6, blind SQLi authentication bypass. Blind SQLi, unlike in-band SQL injection, where we can see the results of our attack directly on the screen, blind SQLi is when we get little to no feedback to confirm whether our injected queries were in fact successful or not. This is because the error messages have been disabled, but the injection still works regardless. It might surprise you that all we need is that little bit of feedback for successfully enumerating a whole database. Authentication bypass. One of the most straightforward blind SQL injection techniques is when bypassing authentication methods, such as login forms. In this instance, we aren't that interested in retrieving data from the database. We just want to get past the login. Login forms that are connected to a database of users are often developed in such a way that the web application is interested in the content of the username and password, but more in whether the two make a matching pair in the user's table. In basic terms, the web application is asking the database, do you have a user with the username Bob and the password Bob123? The database replies with either yes or no, true or false, and depending on that answer, dictates whether the web application lets you proceed or not. Taking the above information into account, it's unnecessary to enumerate a valid username/password pair. We just need to create a database query that replies with a yes/true. Practical. Level 2 of the SQL injection examples shows this exact example we can see in the box labeled SQL query. That the query to the database is the following here. So let's go ahead and copy and paste this. End.b. The username and password values are taken from the user or login form fields. The initial values in the SQL query box will be blank as these fields are currently empty. To make this into a query that always returns as true, we can enter the following into the password field. All right. Yeah. Yeah, SQL query, we see that down here. No results found. And we can try this one as well, right? To into the into the password field, which returns querying something like the following. So let's go ahead and plug this in. All right. Because 1 equals 1 is a true statement and we've used an OR operator, this will always cause the query to return as true, which satisfies the web application logic that the database found a valid username/password combination and the access should be allowed. Answer questions. What is the flag after completing level 2 and moving to level 3? And this appears to be the flag. So let's go ahead and capture this. All right. Now let's go ahead and continue on to task number 7. Task 7, blind SQLi, Boolean-based. Boolean-based SQL injection refers to the response we receive from our injection attempts, which could be a true/false, yes/no, on/off, 1/0, or any response that can only have two outcomes. That outcome confirms that our SQL injection payload was either successful or not. On the first inspection, you may feel like this limited response can provide such or much information. Still, with just 2 responses, it's possible to enumerate a whole database structure and contents. Practical. On level 3 of the SQL injection examples machine, you're presented with a mock browser with the following URL, username equals admin, because we see that here. The browser contains taken true. This API endpoint replicates a common feature found on many sign-up forms, which checks whether a username has already been registered to prompt the user to choose a different username. Because the taken value is set to true, we can assume the username admin is already registered. We can confirm this by changing the username in the mock browser address bar from admin to admin123. So let's go ahead and type that in there real quick, admin123. And upon pressing enter, you'll see the value taken is now changed to false. And you can see that here. The SQL query that is processed looks something like the following here. And select all or star from users where username equals username limit 1. The only input we have control over is the username in the query string, and we'll have to use this to perform our SQL injection. Keeping the username as admin123, we can start appending to this to try and make the database confirm true things, changing the state of the taken field from false to true. Like in previous levels, our first task is to establish the number of columns in the user's table, which we can achieve by using the union statement. Change the username value to the following. All right, so let's go ahead and plug this in. So go ahead and copy this, and you can plug it in up here at the top. Delete all this out of there, and then there we go. As the web application has responded with the value taken as false, we can confirm this is the incorrect value of columns. Keep on adding more columns till we have taken or have a taken value of true. You can confirm that the answer is 3 columns by sending the username to the following value. All right, so you can copy and paste this again. As you can see, we're kind of like walking the database here or web application to determine how many um, columns are back there. So hit enter. Now it's taken as true. So we know that there's 3 columns. Now that our number of columns has been established, we can work on the enumeration of our database. Our first task is to discover the database name. We can do this by using the built-in database open close parenthesis method and then using the like operator to try and find results that will return a true status. Try the below username value and see what happens. So go ahead and copy and paste this out like so. There we go. And let's see. We get a true response because in the like operator, we just have the value of percentage, which will match anything as it's the wildcard value. If we change the wildcard operator to A, so then it starts with an A, you'll see the response goes back to false, which confirms that the database name does not begin with the letter A. We can cycle through all the letters, numbers, characters such as hyphen and underscore until we discover a match. If you send the below as the username value, you receive a true response that confirms the database name begins with the letter S. So if we go back in here and you can go ahead and try cycling through that and see what they're talking about here, but I'm just going to enter this in. Just go ahead and continue on. So now taken is true. All right, now you move on to the next character of the database name until you find another true response. For example, SA, SB, SC, etc. Keep on with this process until you discover all the characters of the database name, which will be SQLi underscore 3. We've established the database name, which we can now use to enumerate tables using a similar method by utilizing the information underscore schema database. Try setting the username to the following value. So let's go ahead and copy and paste here. All right, taken false. This query looks for results in the information underscore schema database in the tables table where the database name SQLi underscore 3, and the table name begins with the letter A. As the above query result in a false response, we can confirm that there are no tables in the SQL underscore 3 database that begins with the letter A. Like previously, you'll need to cycle through letters, numbers, and characters until you find a positive match. You will finally end up discovering a table in the SQL underscore 3 database named users, which you can confirm by running the following username in the payload here. So go ahead and copy and paste this out. See how we did this again? We walked it to determine the name of that table, and it's true. Lastly, we need to enumerate the column names in the users table so we can properly search it for login credentials. We're going to use the information underscore schema database again, and the information we've already gained to query it for column names. Using the payload below, we search the columns table where the database is equal to SQL underscore 3. The table name is users, and the column name begins with the letter A. So let's go ahead and try it again. And we'll have to do the same thing, walk it, skip through all these letters, characters and everything. So it's set to false. All right, cycle through numbers, letter, yada, yada, yada. As you're looking for multiple results, you'll have to add this to your payload each time you find a new column name to avoid discovering the same one. For example, once you found the column ID or named ID, you'll append that to your original payload as seen below. Okay, so yeah, they're excluding ID, right? Column name does not equal ID. All right, so go ahead and plug this in. Repeating this process 3 times will enable you to discover the columns ID, username, and password, which now you can use to query the users table for login credentials. First, you'll need to discover a valid username, which you can use the following payload here. All right, so let's go ahead and copy this. And username is probably going to be admin, I'm sure. All right. Once you cycle through all the characters, you confirm the existence. Yep, username admin. Now you've got the username. You can concentrate on discovering the password. The payload below shows you how to find the password. All right. Same thing. Username is admin and password like A. So you're going to cycle through stuff again. All right, username. And it's false. But as you're cycling through, you'll discover the password is 3845. You can now use the username and password you've enumerated through the blind SQL injection vulnerability on the login form to access the next level. All right, just an example. Let's just type in this 3845. True, true. All right. So 3845 and then login. There we go. Okay. And there is our flag. So let's go ahead and grab that. And then we'll continue on to task number 8. Task 8, blind SQLi time-based. A time-based blind SQL injection is very similar to the above Boolean-based one in that the same requests are sent, but there's no visual indicator of your queries being wrong or right this time. Instead, your indicator of a correct query is based on the time the query takes to complete. This time delay is introduced using built-in methods such as sleepx alongside the union statement. The sleep open close parentheses method will only ever get executed upon a successful union select statement. So for example, when trying to establish the number of columns in a table, you would use the following query. There's the following query here. So you can go ahead and plug this in. If there was no pause in the response time, we know that this query was unsuccessful. So like on the previous task, we add another column. So we do the same thing here. Just going to copy and paste all this stuff out. There we go. See how there's a delay now. This payload should have produced a 5-second delay, confirming the successful execution of the union statement and that there are 2 columns. You can now repeat the enumeration process from the Boolean-based SQL injection, adding the sleep method to the union select statement. If you're struggling to find the table, the below query should help you on the way. And let's go ahead and plug this in here. All right. What's the final flag at completing this level? All right, so sorry, I had to prefer it in there twice. Let me take this out. Okay, so what happened here? Let's see. Let me try pasting this in here. Okay, so it looks like we'll have to cycle through this stuff again. In order to get this one, you'll have to basically cycle through the digits and characters and such, right, to get the password. So I've already have the password in here, but just to show you as an example, I have the query built out here. You press enter, and there's going to be like a 5-second delay, knowing that it was successful. Okay, and then you just basically enter admin and then the password of 4961, and there's the flag. It's a lot of trial and error here. We're dealing with these types of SQL injections. Task number 9. So out of band SQL injection isn't as common as it either depends on specific features being enabled on the database server or the web application business logic, which makes some kind of external network call based on the results from a SQL query. An out-of-band attack is classified by having two different communication channels, one to launch the attack and the other to gather the results. For example, the attack channel could be a web request and the data gathering channel could be monitoring HTTP/DNS requests made to a service you control. Let me just close out of this here. There we go. All right, now let's go back down here. All right, number 1, an attacker makes a request to a website vulnerable to a SQL injection with an injection payload. There you go. Request this website. Number 2, website makes a SQL query to the database, which also passes the hacker's payload. There we go, to the database. And 3, the payload contains a request which forces an HTTP request back to the hacker's machine containing data from the database. Name a protocol beginning with D that can be used to exfiltrate the data from database. Well, we know that's going to be DNS. And let's continue to task number 10 here, remediation. Remediation. As impactful as SQL injection vulnerabilities are, developers do have a way to protect their web applications from them by following the advice below. You got prepared statements with parameterized queries. In a prepared query, the first thing a developer writes is the SQL query, and then any user inputs are added as parameters afterwards. Writing prepared statements ensures that the SQL code structure doesn't change, and the database can distinguish between the query and the data. As a benefit, it also makes your code look much cleaner and easier to read. Input validation. Input validation can go a long way to protect what gets put into a SQL query. Employing an allow list can restrict input to only certain strings, or a string replacement method in the programming language can filter these characters you wish to allow or disallow. Escaping user input. Allowing user input containing characters such as a single quote, double quote, dollar sign, and the backslash can cause SQL queries to break, or even worse, as we've learned, open them up for injection attacks. Escaping user input is the method of prepending a backslash to these characters, which can then causes them to be parsed just as a regular string and not a character. All right, questions. Name a method protecting yourself from SQL injection exploit. And this one looks like it's going to be parameterized or prepared statements. And let's go and plug that in there. There we go. And that pretty much wraps up this video. Hopefully you found this of value. If you did, hit that like button. If you're new here, hit the subscribe button with a notification bell. Hit the comment section below with your thoughts and opinions and information shared. Have you used SQL injection before? Are you familiar with it, etc., etc.? Be sure to check the description area of the video. Always have some helpful resources in there if you want to dig further into web application security and testing, stuff like that. I don't try to do SQL injections too often, but maybe I will in the future. Who knows? But it'll be great to learn more about SQL injection. You can do that with PortSwigger's Web Security Academy. It's got labs and such in there. But as always, thank you all for watching. Have a nice day, and I will see you later.